Hey everybody, welcome back to the fourth video in the Build a Portable Development Environment series. That is a mouthful. This video is all about managing your dot files. So in the previous three videos, we've tackled things like managing packages such as ZSH and Neovim. We've tackled actually configuring these packages. And in this video, we're going to manage our dot files with a new tool. So we're going to introduce a tool called GNU Stow. Now, GNU Stow is a really interesting command line utility that I've kind of discovered in the last few weeks. And given that there's so many ways to actually manage dot files, and I've tried a few of them, this is actually the one I prefer and the one that I'm going to showcase in this video. If you're interested in learning more about GNU Stow, you can check out the website, which I'll link in the description. But we also have this document that we've been kind of maintaining over time, and the link to Stow is also there. Another useful resource that goes well with this video is an article that I wrote on my blog called Manage Your Dot Files Like a Superhero, a little clickbaity title. But this kind of walks through everything that you will need to do to get this set up and running. So you can go ahead and refer to that document or just watch this video because it's going to be the same stuff. Now, throughout this series, we've collected a bunch of dot files that are living in our home directory. We have files for ZSH. We have files for Vim, although we don't really use Vim. We have files in this .config directory for Neovim. We have a ton of stuff. Some of it we want to save. Some of it's auto-generated. We don't really care about. And then, of course, we have the most important aspect of our environment, which is this install file. And we want to kind of collect all of this important configuration and put it somewhere so that we can push it to GitHub and manage it within the cloud. That way, if this computer ever goes down or if I need to set up a new machine, I'm just one command away from having an identical development environment. You will obviously need to have GNU Stow installed to follow along with this video. If you've watched previous videos, you probably already have it installed. Inside of our install sh script, we installed Stow here. This might be something you have already done. If you haven't, and if you're just kind of watching this video without watching the previous ones, you're going to need to figure out how to install that for your specific environment. You can do Homebrew if you're on Linux, if you're on Mac OS, and then Linux, you can do a number of different things. Of course, I recommend Nix because that's what we're using here, but once you have Stow installed, which you can confirm using Stow version, we're going to want to go ahead and create a .files directory. Now, I put my .files directory in my home directory, which on this computer is homejake, and that's also the directory that I'm currently in. And I name the .files directory .files with a dot in front of it. So you can go ahead and create this directory using the command here, make dir .files. And then if I list out my home directory now, you can see I have a new subdirectory called .files. But if I cd into it, we have nothing, right? So we need to start migrating all of our important configuration on our install script into this folder so we can push it up to GitHub. Before we start migrating our configuration and our install script into the .files directory, we have to understand a few pieces of terminology that will explain how Stow works. So in the article I mentioned earlier, there's a section called Understanding Stow. I have a file tree here that describes how you should place your .files within the .files directory. You have a target directory, a Stow directory, and then individual packages. Within these individual packages is where your .files will go. Now you can think of the first one, a package, as just a folder that contains related .files. And these .files are associated with a tool. For instance, Git is a tool, and you may have one or more .files that Git will use when running. Things like git config or a global git ignore. Another example of a package would be ZSH. So in our scenario, we actually have a .zshrc, we have a .zsh plugins.txt, and a .zsh plugins sh file. All three of these are .files, and they're all related to the same package, right? So we would create a ZSH folder and we would store the ZSHRC, the ZSH plugins.txt, etc. We would have another one for Git, and then we'd store our Git config, we would store our Git ignore global, and you can do this for every tool that you have .files for. If you have a Neovim configuration, you can create a package for Neovim. And all of these packages are subdirectories of a stow directory. Now, a stow directory here, I've wrote a stow directory is a folder containing one or more packages. In our case, the stow directory will be the .files directory that we recently created. So if I go back to my command line here, you can see there is a new .files folder. If I go inside of that .files folder, we currently don't have anything, right? But we have ZSH .files, so we can create a ZSH package within the .files stow directory. So now what we have is .files as our stow directory, ZSH as our plugin, and then we can start moving our ZSHRC or our ZSH plugins.txt, right? And the last piece of this puzzle is the target directory. So the stow directory needs to be a child of the target directory. In our case, the target directory would be our home directory. And the reason that is, if I echo home, I'm in home Jake. But if I cd into my .files and then I print out the present working directory, you can see that the .files directory is a child of the home directory. And because we've made this directory our stow directory, then this will be the target directory. I'm saying directory a lot here, but I'm just trying to illustrate how all of this functions. Okay, I brought out Notepad to visualize this a little bit better. So inside of home, we've created a .files folder. And inside of that .files folder, we will have folders for every package that we have .files for, or configuration files. Right now I'm showing ZSH and I'm showing Git, but we have Neovim and Nvim and anything. Maybe you have terminal configuration, right? So your mileage may vary, but at least for this video, we actually don't have Git configuration stuff because that's not something we've gone through, but we do have Neovim stuff. And before we get to that, because it's one step up in complexity, I want to showcase how these files eventually get merged back into the home directory where they belong. So when you have a folder structure like this, home will be your target, .files is your stow directory, and then ZSH is a package where each file within is a .file. And using stow, you are essentially going to be able to quote unquote stow a package, and the tool will take these files and create symlinks and place them in your target directory, so long as the stow directory is within it, right? So right now we have our .files folder, and I'm going to move into that. And inside of the .files folder, we recently created that ZSH package. But if I go inside of there, there's nothing there, right? So what I want to do is I want to go to my home directory, and I want to move the relevant files that are in the home directory, and I want to move them into that ZSH package. So I can use a command called mv or move. I can specify the file that I want to move, and then I can specify where I want to move it. So I want to move it in a .files ZSH, and I believe you also have to name it as well. So if I do that, and then I relist the home directory, you can see ZSHRC is no longer there, right? So now I'll go into .files ZSH, I'll ls, and we have our ZSHRC file. Let's just hop into that within Vim to make sure nothing has changed, right? Everything is there. Now, that's not the only file. So let's go back, and we also want to move this one. So we'll say move ZSH plugins.txt to .files ZSH plugins.txt. If I ls now, zsh plugins.txt is gone, and we can assume that, you know, it's certainly inside of this zsh package, right? Cool. Now, zsh plugins sh is kind of a special case because we generate this. We generate it the first time within our install script. So at the bottom of our install script, we will generate it utilizing the zsh plugins text file. And I believe inside of our zshrc, if I go into Dotfiles, zshrc, that's where we source it. And anytime we make a change to our plugins.txt file, we need to resource, but that's something that you can do on your own, right? Therefore, it's not required to put this zsh plugins.sh file into your zsh package because, again, it will be created. And that goes for a number of other dot files within your home directory. There's just some that you don't want to commit to source, right? You don't need to commit them to source because they're auto-generated. Example of this would be the power level 10K. It's going to get generated, no reason to keep it. Now that we've moved these files outside of our home directory and into the Dotfiles directory, we need to stow the ZSH package. So I'm going to go into Dotfiles. Currently, I just have the one package called ZSH. And so the next step will be to use the stow command on the ZSH package. Now, when you run the stow command, there is no output, so you're not going to see anything. If you ls the ZSH directory, you're not going to see anything. Your dot files are still there. However, if I go to my home directory, which remember, the home directory is our target, then what I will see is symlinks. And so what we have, and the symlinks are denoted by these arrows, right? So what we have are symlinks to the .files version of the file. And this occurs when you run the stow command. So essentially, stow is placing symlink versions of a file that point to the original source, which is in the .files directory, which we can then push to GitHub. Let's do another example here. Let's maybe make a git ignore global, right? So I'm going to go into cd.files. I'm going to create a new directory called git. I'm going to cd into git, and I'm going to make a .gitignore global. And I'm just going to ignore node modules, right? That's a pretty common folder to ignore. And using the git ignore global, I never have to write this in a project's git ignore. It will just always be picked up. The thing though is that this git ignore global file needs to be in my home directory, and currently it's not. It is inside of this directory. So if I pop back out into the .files folder, you can see I have my ZSH package, and now I have a new package called git. If I stow that git package and I go into my home directory and I list it, I now have a git ignore global symlinked file pointing to that original git ignore global file. And this is exactly what we want. So you can imagine this entire directory, not all the files, but a lot of them will just be symlinks pointing to the original file, which is hosted inside of the .files folder. We have ZSH stowed, we have git stowed, but we still haven't done anything about Neovim. And Neovim is actually a special case, and that's why I left it last. If you go to the home directory, and if you've been following along with this series of videos, you should have this .config directory. Inside of that, and it's actually a common directory that a lot of tools use to store their configuration, you will have an nvim folder, and inside of that, you will have the init.vim configuration file. And I can open up init.vim, make sure it's all there, right? So we need a way to store this inside of our .files directory, but it's actually not as simple as the others. And the reason for that is because of the nesting that's going on with the folders. What we actually want to do is describe to stow that the entire .config/nvim directory wants to be stowed. The way we do this is we go into our .files directory. Remember, we have to make a package for Neovim. So I'm going to create an nvim. Oop, that's not how you spell make dir. An nvim package. So now I have git, I have nvim, I have zsh. If I go inside of nvim, obviously it's going to be empty. However, if I were to place an init.vim right in the root of the nvim package, what will end up happening is Stow will symlink the init.vim in the home directory, but we don't want it there. We want it in the .config/nvim directory. So we model our package folder structure the same way we expect Stow to store the files or to symlink the files within the target directory. So I'm going to create a .config/nvim directory. Oh, I have to do, I think it's -p. No, there we go. Okay, so now let's walk back a bit. We have our nvim package. Inside of our nvim package, we have a .config folder. Inside of our .config folder, we have an nvim folder. And inside of this nvim folder, we have nothing. But if you view the package directory as a model of what should be in the home directory, then it makes sense, right? Dotfiles is the Stow folder, nvim is the package folder, and everything within the package folder is going to be symlinked. So we need to move our init.vim here. So I'm going to go back to the home directory. I'm going to cd into config nvim, and you can see the similarity, right? And I want to move init.vim to the home directory .files nvim .config/nvim init.vim. So now if I cd into the .files directory, I'll cd into the nvim package, and then I have to kind of drill down here, and boom, we have init.vim, right? There are a few other files that we want to store along with init.vim. We want to store this autoload directory as well. If you remembered in the last video, this autoload directory is actually what houses our vim plug file, or our plug.vim file. And we can host this within GitHub too. I'm going to move the autoload folder to home.files nvim config nvim autoload. Actually, it should be like that. So now autoload is gone. And autoload exists there. And if I go into autoload, boom, I have my plug.vim. The other folders inside of the config nvim directory are generated when we run Neovim or when we install plugins. So we don't need to commit them to source. The files up here are plenty enough. Now that we've ported over our Neovim configuration into the .files directory, and we've created a Neovim package, we can go ahead and stow that package the same way that we stowed git and zsh. So I will run stow nvim, and remember, nothing will change in the .files directory, but now if I go to my home directory and I list it, we have the .config, and if I go inside of .config and I go inside of Neovim, we now have two symlinks pointing to those specific files. Cool, so we have Neovim stowed, we have zsh and git stowed. I think based on everything we've done in the series, that is plenty. There's no other .files that I really care about here, that I care to stow here, because they're all pretty much auto-generated or useless to our environment. For instance, bash, and we don't use bash, or at least we haven't used bash in this example. So we don't need to worry about that. Cache directory is auto-generated. We've worked with config. This is ours. All of this stuff, Nix is auto-generated. So these things are not something you want to maintain and store within GitHub. But we do want to move this install script. So I'm going to move install.sh into our .files directory, but we're not going to stow it. And I'll explain why. So if I go inside of .files and I list it out, we have our packages, and then we have the install.sh file. So in practice, what we want to do is we want to push this entire directory to GitHub, and then next time you clone it, you would run this script from within the .files directory, and it would do all the architecture and infrastructure setup, and we're good to go, right? Now, before we wrap this entire video up, we do need to update the install.sh script to actually stow these files. So imagine you've just pulled down the .files directory and you cloned it on a new computer. You cloned it to this .files folder, and it now includes all of this information. But what we didn't do is symlink all of the files within. What you'd end up having is a home directory that's void of any ZSH configuration. It's void of any Git or Neovim configuration. So ideally, what you'd want to do is clone it, run the install script, and within the install script, you stow Git, Neovim, and ZSH, or whatever other packages you have. So I'm going to open up the install.sh executable, and I'm going to put our stow command right here. I'm going to stow all of our packages. And so if we read this from top to bottom, what ends up happening when this script runs is we install our Nix package manager, we source it, and then we go ahead and we install all of our packages, ZSH, Antibody, Git, Neovim, etc. Stow is there as well, which is a crucial step, by the way, because in the next series of commands, we use stow. So then we're going to stow the Git, ZSH, and Nvim packages, which are within the .files directory. Once these three packages are stowed, all of the .files will be symlinked in the home directory, which will allow us to do something like this and use one of those symlinked files to generate our ZSH plugins.sh file. So I will save this. And at this point, we are pretty good to go. There is not much that needs to be done except for pushing our .files content into GitHub. Now, I have a .files directory in GitHub already, and you can see it's very similar to what we have in the Linux environment. I have a Git package, an Nvim package, a ZSH package, an install.sh file. I have a README. I have a git ignore as well, which I've added a few things that get ignored. And I have a ZSH package, a tmux package, an Nvim package that's nested because, again, we have to put all that stuff in a .config directory. Kitty is a terminal that I use on Mac OS, and again, that stuff goes in a .config directory as well. And then I have Git. So I don't need to push this package up to GitHub, but if you wanted to, all you'd have to do is go to GitHub. I'm not signed in apparently. I think this is Brave browser, but you would obviously be signed into GitHub. You'd create a new remote repository, call it whatever you'd like, and then you can make this .files a Git directory, add the remote, push it, and then now all of your configuration is up to date, and anytime you make a change, it will act as a traditional Git project, and you can Git status and Git diff, all of the changes. You can create branches. These are things that I've done in the past. For instance, when I'm using Neovim plugins and I want to try a different configuration, I will actually create a brand new branch in my .files directory and completely change my Neovim configuration on that specific branch and just play around with it for a little bit, see how I like it. And that's the great thing about hosting this .files directory in Git with Stow. That's going to wrap it up for this video. I hope you learned something and enjoyed it. This is the 4th video in the Portable Development Environment series. So if you haven't watched the other 3, I'd highly recommend it. It definitely provides some context going into this video. There is going to be one more video that I'm going to make for this series, and that's going to wrap it up. And it's actually going to be about cloning your .files directory from GitHub on a brand new machine and running the install script. We've been building this install script for 4 videos now, and we actually haven't executed it once. So what I'm going to do is completely wipe this environment to a bare bones installation and then clone the .files directory from GitHub and run the install script, and we're going to see how it works. So if you're interested, stay tuned for that, and thanks for watching.